We're starting permutations and combinations. Permutation is applied when the arrangement of the objects matter. For example, if a number has to be formed, then if it was a 4-digit number using the numbers 2, 3, 4 and 5, if 2 came first it would be a different number, but if 2 came last then it would be a different number. So that's why permutation will be used over here. Then for example, if a word has to be formed, then again we'll use permutation. But if we have to select a team of 6 people, then as it does not matter whose name comes first, combination will be used. So now we'll do some questions of it. The first question says, find how many different 4-digit numbers can be formed using the digits 1, 2, 3, 4, 5 and 6 if no digit is repeated. So it's 4-digit number and there are 1, 2, 3, 4, 5, 6 numbers. As we have to form numbers, so we'll use permutation. So out of 6 we need 4, so it's 6p4. $360. The next part is how many of the 4-digit numbers found in part 1 are greater than 6,000. Now for the numbers to be greater than 6,000, they should start with 6. So we'll write 1p1 as 6 is a must at the first position into 3 out of the 5 remaining. It's 3 because we had to have a 4-digit number, and 5 because 5 plus 1 is 6. We have total 6 digits. So this will be 1p1 into 5p3, 60. Next part says how many of the 4-digit numbers found in part 1 are greater than 6,000 and are odd. For a number to be odd, it should end in 1, 3 or 5. And as it has to be greater than 6,000, so it will start with 6. So 1p1 into, it will end in 1, 3 or 5. So 1 out of any 3 of them will end with. And then we are left with 4 more digits and 2 more places. So 1p1 into 3p1 into 4p2, 36. The next part says a quiz team of 10 players is to be chosen from a class of 8 boys and 12 girls. Find the number of different teams that can be chosen if the team has to have equal number of girls and boys. Now, as there have to be 10 players, so there have to be 5 boys and 5 girls. The 5 boys have to be chosen from 8 of them. Now as the position of the boy does not matter over here, so we'll use combination 8c5 into 5 girls out of 12, so 12c5 equals to 4, 4, 3, 5, 2. The next part says find the number of different teams that can be chosen if the team has to include the youngest and oldest boy and the youngest and oldest girl. So here this means that 2 of the boys have to be selected and 2 of the girls have to be selected. So we'll write 4c4 into, we have now left, out of 24 have been selected, so 16 students remain, and out of those 6 have to be selected. The next question says a security code is to be chosen using 6 of the following. So the length of the code has to be 6 digits. Now there can be the letters A, B and C, the numbers 2, 3 and 5 and the symbols star and dollar. None of the above may be used more than once. Now we have to have a security code of 6 digits, and the possibilities are 1, 2, 3, 4, 5, 6, 7, 8. Now over here the order would matter because, for example, if A was the first one in one and A was the last one in another, so those would be 2 different security codes. So we'll have 8p6. that is 20160. Next part is the security code starts with a letter and finishes with a symbol. Now there are 3 letters and it has to start with one of those. So 3P1 into, it has to end with one of the symbols out of those 2. So 2P1. Now 2 have been taken out of those 6. We have 2 have been taken out, used from those 8. So we have 6 more remaining digits that can be used, and we have 4 more spaces remaining as 2 have been filled. So 6P4. Again, we're doing this again. There are 6 digits that we need, and we have 8 possibilities. Now on the first one, we need to have a letter out of these 3. So we'll have 3P1 over here. At the last one, we need to have a symbol from these 2. So we have 2 possibilities, 1 is needed, so 2P1. Now we have 4 more spaces, and out of these 8, as 2 have been used, we have 6 more digits. So for the rest of them, it's 6P4. In the next part, the 2 symbols are next to each other in the security code. So we have 6 places to fill. Now the symbols have to be together. So either the symbol will be at these 2 places, or at these 2 places, or at these 2 places, or these, or these. Now these are 1, 2, 3, 4, 5. 5 places where the symbols can be. And what if the symbols are reversed? So there are 10 places that the symbols can be. Now this is for the symbols. Now for the other 4 digits, we have 6 possibilities. 1, 2, 3, 4, 5, 6. So into 6P4. Is equals to 3600. The next question says 2 teams, each of 4 students, are to be selected from a class of 8 boys and 6 girls. Find the number of different ways the 2 teams may be selected if there are no restrictions. So there have to be 2 teams, and there are total 14 children. 2 teams of 4 students. Out of these 14, if first we take 4 children for one team, and then out of the remaining 10, 4 children for the next team. 14C4 into 10C4. This is equals to 210, 210. So first, out of the 14 people, because there were no restrictions, we took any 4, and then 14 minus 4 is 10. Out of those 10, we took 4 more. So 210, 210. Now the next part says that one team is to contain boys only, and the other team is to contain girls only. Now there are 8 boys, and we have to select 4 out of those. So 8C4 into, there are 6 girls, 6C4. That will be 1050. Next question says 6 books are to be chosen from 8 different books. Find the number of different selections of 6 books that could be made. So this means that the order of the books does not matter over here. So we'll have 8 combination 6 is equals to 28. The next part says a clock is to be displayed on a shelf with 3 of the 8 different books on each side of it. Find the number of ways this can be done if there are no restrictions on the choice of books. Now there have to be 3 books like this, and then the clock, and then 3 books like this. Because they're saying number of ways, this means that we have to find all the possibilities, and over here that's why the order will matter. So it will be 8P3, and here as 3 have been taken out, so 5 remain, 5p3. This is equals to 20160. The next part says 3 of the 8 books are music books which have to be kept together. Now either these 3 books will be on this side or on this side. So we'll have, the next part says 3 of the 8 books are music books which have to be kept together. This means that either these books are on this side or on this side. So for those 3 books we'll take them as 1 unit, so 1p1 into, as 3 have been taken, 5 remain, so 5p3 for the other side. And in those 3 books, like if they are on this side of the clock, this is book A, B, C. To find the arrangement of these, we'll write 3p3. Now it's also possible that these 3 books are on the opposite side, so it will be into 2. This is equals to 720. The next question says a team of 6 tennis players is to be chosen from 10 tennis players consisting of 7 men and 3 women. Find the number of different teams that could be chosen if the team must include at least 1 woman. Now this means that there could be 1 woman, 2 women, or 3 women. So first we'll take 1 woman. For this we'll have out of 3, 1. As we needed 5 total players, so out of the 7 men, we needed 6 total players, so out of the 7 men we'll take now 5 as we've got already 1. Then plus for 2 women, 3c2 into 7c4, plus for 3 women, 3c3 into 7c3. This is coming equals to 203. The next question says how many even numbers less than 500 can be formed using the digits 1, 2, 3, 4 and 5. So even numbers less than 500 can be 1 digit, 2 digit or 3 digit. For 1 digit they can be 2 or 4, so 2p1. For 2 digit they should end with 2 or 4, so for the last one we'll write 2p1 into, they can start with any 4 of the others, so 4p1. For a 3 digit even number less than 500, it should not start with 5, it should end with 2 or 4. So if it starts with 1 or 3, we'll have 2p1 for the first digit, 2p1 for the last digit out of these 2, and then 3p1 for the third digit, plus. Now if this number starts with 2 or 4, so we'll have 2p1 for the first digit and then 1p1 for the last digit because only one of these even numbers will remain, and then 3p1 for the middle digit. This will be 28. The next part is a committee of 8 people is to be chosen from 7 men and 5 women. Find the number of different committees that could be selected. Over here there is a group of people, so we'll be using a combination as the position does not matter. So the committee contains at least 3 men and at least 3 women. If there are 3 men, then there will be 5 women. If there are 4 men, then there will be 4 women. And if there are 5 men, there will be 3 women. So for 3 men, we'll have 7c3 into 5c5 plus 7c4 into 5c4 plus 5c5 plus 7c5 for men into 5c3. This will be equals to 420. Now if the oldest man or the oldest woman have to be selected, so we have one oldest man, one oldest woman, and then there are 10 more people. So either there is the oldest man, and out of the rest of the 10 people there will be 7, or the oldest woman, and out of the rest of the 7 people. So it will be a combination because there is a group of people, not a permutation. This will be equals to 240.